Hello students, so in this video we will be covering the questions of continuity and differentiability in particular. So before watching this video, I recommend all of you to kindly watch limits, continuity, differentiability part 1, in which the questions of limits are discussed, because watching this video requires knowledge of limits, right? So before watching this, once again I am reminding, please do watch part 1. Okay. Now let us jump into the first question. The first question says f of x is a limit theta approaches to 0, cos of pi x minus x power 2 by theta sine times x minus 1 by 1 plus x power 2 by theta into x minus 1. Acha, here x belongs to R. Consider the following two statements: f of x is discontinuous at 1 and f of x is continuous at minus 1. So we need to check the continuity basically at 1 and minus 1. So so here it's a multivariate type of question, because there are two variables here. First is theta is approaching to 0 and also x is approaching to 1 and minus 1. So we need to analyze the behavior of theta first and then the behavior of this function at x equals to 1 and minus 1. So what shall be done? See here, whenever we have theta is approaching to 0 and we have something divided by theta, directly we should not replace theta with 0, because theta, if it's approaching to 0 plus, let us say theta is approaching to 0 plus, that means if we find right hand limit, then this value will approach to plus infinity, and let us say theta is approaching to 0 minus, then this value will approach to 0, because 2 by 0 minus will approach to minus infinity and x bar minus infinity will approach to 0. Acha. Now here also there is a twist, right? For that we need to know the value of x, right? See, for no, we know that if mod x is less than 1, right, if mod x is less than 1 and 1 minus whole bar infinity, something rises to infinity, this will approach to 0. And if mod x is greater than 1, now 1 plus infinity will approach to infinity, right? And exact 1 bar infinity will be equals to 1 bar approaching to infinity will be equal to 1. I hope you are aware of this. So that means now the question breaks down into this part. So we will do one thing. We will take let t be equals to 2 by theta. Okay, let us say t be equals to 2 by theta. As theta approaches to 0, t approaches to infinity, right? Plus infinity or minus infinity, depends. So we will write down f of x as limit t approaching to infinity into cos pi x minus x power t sine of x minus 1 divided by 1 plus x power t into x minus 1. I hope you are with me, right? So is this clear? Yeah. Now the point is, if mod x is less than 1, so let us take this as case 1 or whatever. Case 1, if mod x is less than 1, what will happen? If mod x is less than 1, this value will approach to 0. Yes, as per this logic. Correct, no? Mod x is less than 1, this value will approach to 0. Perfect. And this will also approach to 0. That means f of x now becomes simply limit t approaching to infinity. Now limit is not required, because that will anyways approach to 0. Now this will simply be equals to cos pi x. Okay. This is true if mod x is less than 1. That means x belongs from minus 1 to 1. I hope you are with me, right? Okay. Now what does the case 2 imply? If mod x is greater than 1, then f of x will be limit t approaching to infinity cos pi x minus x power t times sine of x minus 1 divided by 1 plus x power t times x minus 1. Acha, if t is approaching to infinity and mod x is greater than 1, then this value will approach to infinity, right? So directly we will not replace. So in these cases, dear students, you should be knowing that we should be taking x power t common, right? So if I take x bar t common, I'll be getting x bar minus t into cos pi x minus sine times x minus 1 divided by, if I take x bar t common, I'll be getting x bar minus t here plus x minus 1. I hope you are with me, right? Now we can definitely cancel this. So we get limit t approaching to infinity. Yeah. Now, once we cancel this, right, so now as t approaches to infinity, and if mod x is greater than 1, it is something like this. Let us say x is 2. So 2 raised to the power minus infinity will approach to 0, right? So in that case, this value will be approaching to 0, this value will be approaching to 0. Hence we get f of x as minus sine times x minus 1 divided by x minus 1, and this will be true if this will be true if mod x is greater than 1. With respect to this, what can we say? That means x belongs from minus infinity to minus 1 union 1 to infinity, right? I hope you are with me. Okay. So f of x ultimately becomes this function, that it is cos pi x, and this is true if x belongs from minus 1 to 1, and minus sine times x minus 1 divided by x minus 1. This is true if x belongs from minus infinity to minus 1 union 1 to infinity. In addition, if you want, you can evaluate the value of the function at 1 and minus 1 also. So if you want at x equals to 1, what happens is, let us see that if it is required or not. We need to just check the continuity at 1 first, discontinuity at 1 first. Continuity of f of x at x equals to 1. For that, we need the value of f of n definitely, but let us see the left hand limit and right hand limit. LHL, that means limit x approaches to 1 minus. So if it is 1 minus, which definition shall we use? We will be using this definition. So the definition will be cos pi x, and this value will be minus 1. And RHL, right, is limit x approaches to 1 plus, right? So 1 plus, which definition shall we use, dear students? This definition. So we have negative of sine of x minus 1 divided by x minus 1. So what do we get here? As x approaches to 1 plus, this value will approach to minus 1. Okay. We need to find the continuity at 1 also. 1, right? So that means we need to find the value of f of 1 also. So, okay, how did we get this as minus 1 first? Because we can take minus outside and limit x approaches to 1 minus 1 plus. This value will approach to 0, and this numerator will approach to 0. Denominator also will approach to 0. Hence, this value is 1, right? Because standard limit x approaches to 0, sin x by x is 1, right? Okay. But directly we cannot say that the function is continuous at 1, because LHL is equals to RHL, yes. But what about value of the function at 1? So we need to find f of 1 also. For that, what will we do is, we will take this definition, right? F of 1 will be limit theta approaches to 0. Let me write it here. F of 1 will be limit theta approaches to 0. So this value becomes simply 0. 1 power infinity, I just told this value will be 1, approaching to 1. This value will also be approaching to 1. This value will be approaching to, this value will not be approaching to 0. This value is exactly equal to 0, dear students. Please note the point. Sine of x minus 1 will exactly be equal to 0, because x is equals to 1. Sine 0 is 0, right? Exact 0 into approaching to 1 is 0. So ultimately we get limit theta approaches to 0 cos pi x, right? So now f of 1 is simply cos pi into 1. So cos pi is minus 1. So therefore LHL is equals to RHL is equals to f of 1. Therefore f of x is continuous at x equals to 1. Is this clear? Yeah. That means, okay, that means statement 1 is false. F of x is discontinuous. No, it is, statement 1 is false. Okay, statement 1 is false. Now we need to check the continuity at minus 1. Okay, so again, checking the continuity at the rate x equals to minus 1. So first LHL, that means limit x approaches to minus 1 minus, right? From left hand side we are approaching. So that means it should be less than minus 1. Which definition shall we use? So again we will be using this definition. That means we will be writing negative of sine of x minus 1 divided by x minus 1. So we can write this as negative limit x approaches to minus 1 minus sine of x minus 1 divided by x minus 1. Now we can replace x with minus 1. Since the denominator is not 0, we get sine of minus 1 divided by minus 1. We get sine of negative of sine of minus 2 divided by minus 2. So ultimately we get minus sine 2 divided by 2. And what is RHL? RHL means limit x approaching to minus 1 plus. So it should be more than minus 1. It should be more than minus 1. If it is more than minus 1, that means we should be using this definition now. Correct? So we have cos pi x. Again we will write this as cos pi into minus 1, and cos of minus pi is same as cos pi, which is same as minus 1. That means LHL is not equal to RHL, dear students, and we need not find the value of f of minus 1 since LHL is not equal to RHL. Therefore f of x is discontinuous at x equals to minus 1. And what does the statement 2 state? Say it is continuous, that means statement 2 is also false. Statement 2 is false. That means what? Only 2 is true? No. Both 1 and 2 are true? No. Neither 1 nor 2 is true. So this should be the correct answer. I hope you understood this question. So this is a very important model. If you have not understood this, please rewind the video and watch it again. Okay. Now let us go to the second question. Dear student, second question says let alpha beta belong to R be such that the function is differentiable. Okay. Now this is a question on differentiability. Okay. Let me recall the concept. If f of x is differentiable, then f of x must be continuous, right? Correct, no? That means first, I think he's asking us to find the value of alpha and beta expected. So it's a very simple question. We will find LHL. We will say LHL is equals to RHL is equals to f of 1 because it is differentiable for all x belongs to R. That means it should be differentiable at 1. That means it should be continuous at 1, right? So LHL at f of 1 means we will be using this definition. Simply LHL means limit x approaches to 1 minus. The definition will be 2 alpha times x square minus 2 plus 2 beta x. That should be equals to limit x approaches to 1 plus. So we will be using this definition, alpha plus 3 times x plus alpha minus beta. So what will we get here? We will be writing this as replace x with 1. We get 2 alpha into 1 minus 2 is minus 1 plus 2 beta into 1, and that should be equals to alpha plus 3 plus alpha minus beta. Alpha plus 3 into 1 is alpha plus 3, right? So minus 2 alpha, and here so we'll write minus 2 alpha plus 2 beta is equals to 2 alpha plus 3 minus beta. On rearranging we get 4 alpha minus 3 beta plus 3 equals to 0. This is one equation, right? Now this is a standard question, dear students. Here we know what will we be doing next. Now we will be applying the test of differentiability. Since it is differentiable, we will write f dash of x is equals to differentiate it. So derivative of this part will be 2 alpha into 2x, 2 alpha into 2x plus 2 beta. Derivative of 2 beta x is 2 beta, and this is true for x is less than 1. Don't differentiate this. This is the condition, okay? And alpha plus 3 times x, derivative of alpha plus 3 times x is alpha plus 3. Derivative of alpha minus beta should be 0. This is true if x is greater than or equal to 1. So dear students, here the note point is, if we are checking the differentiability at 1, we will not place this equality. But since it is differentiable, so we can equate this. We should equate this, not we can. So again, f dash of 1 minus is equals to f dash of 1 plus. What does this mean? This means left hand derivative is equals to right hand derivative. So what is f dash of 1 minus? We will be using this definition. 2 alpha into 2 into 1 plus 2 beta. That should be equals to alpha plus 3. So we get 4 alpha plus 2 beta is equals to alpha plus 3. That means 3 alpha plus 2 beta minus 3 equals to 0. Now this is equation 2. So if I solve equation 1 and 2, we will be getting the value of alpha and beta. So how do we solve? We'll do one thing. We'll multiply equation 1 with we'll eliminate beta. So we'll multiply equation 1 with 2. So we get 8 alpha minus 6 beta plus 6 equals to 0, and we'll multiply equation 2 with 3. So we get 9 alpha plus 6 beta minus 9 equals to 0. So if I add, I'll be getting 17 alpha minus 3 equals to 0. That means alpha equals to 3 by 17. If alpha equals to 3 by 17, we write 4 into 3 by 17. Substitute this in equation 1. We will be getting the value of beta. So 4 into 3 is 12. 12 by 17 plus 3 is equals to 3 beta. So we can cancel this. So we get beta is equals to 4 by 17 plus 1, which is 21 by 17. Okay. So alpha is known and beta is known. I think now the question can comfortably be solved. So what is he asking? 34 times alpha plus beta. So 34 times what is alpha? Alpha is 3 by 17. And what is beta? Beta is 21 by 17. So we will get 34 times 21 plus 3 is 24 divided by 17. 17 times 2. So we get 48 here. Option A is correct. That's it. Very simple question. So this type of questions you should definitely, we can expect this in shift 2 also, dear students. So this type of questions, please practice it more so that you will definitely score +4 in the next shift. Okay. Now the next question says if the function f of x is equals to e power x into e power tan x minus 1 plus log of secant x plus tan x minus x divided by tan x minus x is continuous at x equals to 0. Then the value of f of 0. That means what does the definition say? Limit x approaching to 0, f of x should be equals to f of 0, right? So we need to basically find limiting value. Now this is a standard limits question, so we can write limit x approaches to 0. F of 0 will be Yeah, now let us see here we have tan x minus x here and tan x minus x here also. We'll do one thing, we'll split the limits. So we'll write e power x into e power tan x minus 1 divided by tan x minus x plus limit x approaching to 0 log of secant x plus tan x to the base e minus x divided by tan x minus x. Okay, right, we can split it. Acha, when now this is product, right? X approaching to 0, e power 0 will this will approach to 1, so this we can straight away nullify. So we get, now this is of the form limit x approaching to 0 e power tan x minus 1 by tan x minus x, right? Acha, this value will be 1. Why? Because this value is approaching to 0, correct? Tan 0 minus 0, tan 0 is 0, and this value is also approaching to 0. So by standard limit this value will approach to yes, it should approach to 1. Okay, what about this fellow, the right, this part? Acha, when x is approaching to 0, secant 0 is approaching to 1 and tan 0 is approaching to 0, so we get log 1 is approaching to 0, and yeah, so that means numerator is approaching to 0, denominator is also approaching to 0. So one thing is we can think of L'Hopital rule. So here for this part apply LH rule. So what do we get? Limit x approaches to 0, differentiate the numerator and denominator independently. So derivative of log of something is 1 by something into, acha, if you know basic integration, no? So on integrating, what do we get this? Yeah, secant x. So this derivative of this simply should be secant x. So if you are doubtful, how are we getting this? Differentiate this part, we will be getting secant x. And derivative of x is 1. Derivative of tan x is secant square x, and derivative of x is 1, right? So this, okay, now I think this is very, very simple. Okay, this part is approaching to 0. If you are doubtful, again dear students, here also you can apply LH rule. You will get this as 1. And here you can write this as limit x approaching to 0, secant x minus 1 into, acha, divided by secant x minus 1 into secant x plus 1. Definitely we can cancel this, since this is approaching to 0 and this is also approaching to 0. We can cancel it, not a problem. And so we are left with limit x approaching to 0 by 1 by secant x plus 1. So this should be 1 by 1 plus 1, which should be 1 plus 1 by 2, which is 3 by 2 should be the answer. F of 0 is 3 by 2. 3 by 2, yes, this is the answer. Perfect. Option D is correct. Now let us go to the next question. Next question says f of x is equals to a mod x plus x square minus 2 times sin of mod x into cos of mod x by x. Achha, this is true if x is not equal to 0, and it is equals, if x is 0, the value is b. Okay, so what is he asking here? He is asking us to find the value of a plus b. Again an expected model, dear students. Again the same definition as the previous question, limit x approaches to 0, f of x should be equals to f of 0. But here the twist is we need to find LHL and RHL separately because mod x is there, right? So how does the mod x function behave? Mod x will be equal to x if x is greater than or equal to 0, and it will be equal to minus x if x is less than 0. So first we will find the LHL, left hand limit. That means limit x approaches to 0 minus, what will I get here? I will be getting minus ax. Okay, I will be getting minus ax, and here I will be getting plus x square minus 2 times. Now I will be getting sin of minus x into cos of minus x divided by x, right? Okay, so this value will be limit x approaching to 0 minus minus ax plus x square. Sin of minus x is minus sin x, so we get plus 2 sin x, and cos of minus x is plus cos x, right? Now can we split the numerator? Yes, definitely. Right, and I think now we can easily calculate this. So x and x gets cancelled, so we get minus a, and this value will be 0, and sin x by x should be 1. Limit x approaches to 0 minus sin x by x should be 1, and cos 0 should be 1, right? So we get this as minus a plus 2. This is left hand limit. What about right hand limit? For right hand limit, now mod x will simply open with a positive sign, so here we get limit x approaches to 0 plus, this should be a into x plus x square minus 2 times. Now sin of, instead of mod x we can simply write x here, so here we write sin x into cos x. Again split the limit, so now this will be x and x gets cancelled. Here we get a plus 0 minus 2 into, now this value is 1 into cos 0 is 1, so we get a minus 2. Acha, since it is continuous at 0, and what is f of 0? F of 0 is b, right? That is Okay, so f of 0 is b, that is given in the question. So what can we say? We can say that left hand limit, that is minus a plus 2 is equals to right hand limit a minus 2, that is equals to b. So if I equate these two, I get minus a plus 2 is equals to a minus 2. That means 4 is equals to 2a and a is simply equals to 2, right? I hope I am correct. Yeah. That means if a is 2, b is simply 0, right? So what is a plus b? A plus b is 2 plus 0, that should be 2. So that's it. This should be the correct answer. That's it, as simple as that. Right, now, yeah, so the other questions we'll solve in the next video, dear students. Thank you for watching this.